Hi, it's Mr. Baker here, and today we're going to be looking at centripetal force. Okay, so today we're going to be looking at centripetal force. We looked at centripetal acceleration before. Any object moving in a circle has a changing velocity, even if it is moving at a constant speed, because its direction is changing. It's always moving along a tangent to the circle. So we've got three diagrams here of an object moving around in circular motion. Over time you can see that the velocity, although the arrows are the same size, they're changing direction, and so therefore the velocity must be changing. As acceleration is the rate of change of velocity, therefore any object moving in a circle is accelerating, and this is called the centripetal acceleration. So this is what we've looked at in a previous lesson, and today we're going to move that on a little bit and look at centripetal force. So according to Newton's second law, force equals mass times acceleration. Here we've got a Ferris wheel moving round in a circular motion. Acceleration and force therefore act in the same direction as one another. It can therefore be shown that the direction of centripetal acceleration, A, is towards the centre of the circle. This is perpendicular to the direction of the velocity V. So here we've got our arrow V, which is going at a tangent to the direction of this circular motion, and the acceleration A is going towards the centre of this circle. So we've seen the acceleration and we've actually derived some equations for it. We've got our equation here that A is v squared over r, and we've got that A equals omega squared r. So here we've got v as velocity, r as the radius of the circle, and A as our acceleration, our centripetal acceleration. Here we've got A as centripetal acceleration again, we've got r as radius again, and here we've got omega as the angular velocity. So it's not too difficult to then move on from acceleration, knowing that Newton's second law says that F equals ma when we've got a constant mass. All we've got to do is literally put an m in front of that. So for F equals ma, for our first equation we just put an m in front, so we get mv squared over r, and for our second equation we just get F equals ma, which is m omega squared r. Okay, so these are our two equations then that we've derived. The equation for the force on an object following a circular path, the centripetal force, is either going to be mv squared over r or m omega squared r. Fairly straightforward, hopefully. So this is what you should be able to do by the end of the day. You should be able to describe what centripetal force is, and you should be able to state the equation for centripetal force. Okay, well that's it for today. I have been Mr. Baker. Thank you very much, and I will see you next time.